This video is over solving radical equations. And the first thing we have is if a equals b, then a squared equals b squared. And you guys know that. So if I had a plus b equals c plus d, then that's the same thing as saying a plus b as a quantity squared will equal c plus d as a quantity squared. But you just have to keep in mind you can raise both sides of an equation to an exponent. You can't raise individual pieces of it. You have to do one side squared equals the other side squared. So let's do some example problems. Alright, let's solve for x. We've got the fifth root of x plus 2 equals 1. So the first thing we're going to do is subtract 2 from both sides, and we have the fifth root of x equals negative 1. And then we're going to raise both sides to the fifth power, because that's how you undo a fifth root. And so we have x equals, and if you take negative 1 to the fifth power, you get negative 1. So we have x equals negative 1. Now, whenever you are solving radical equations, you must always check them. And you always want to do this by going to the original problem here. Not anywhere after you've simplified. To the original problem and say the fifth root of negative 1 plus 2 equals 1. And you just want to solve the right-hand side and solve the left-hand side. So the fifth root of negative 1 is negative 1. And then we say plus 2 equals 1. And negative 1 plus 2 is 1. 1 equals 1. Yay, it checks. So this is a good answer. For this next example, we're going to solve 2 times x plus 1 all raised to the 2/3 power equals 8. So the first thing we're going to do with this problem is divide both sides by 2. And we'll have x plus 1 to the 2/3 power equals 4. And then when you have your power as a rational exponent, you can think, what would I raise this to get rid of it? And that would be raising it to the reciprocal. So I'm going to raise both sides to the 3/2 power. So that gives me x plus 1 to the 2/3, and then raise that to the 3/2 equals 4 to the 3/2. So do you see that this times this is 1, and now we just have x plus 1. And then 4 to the 3/2, since we are doing a square root, we actually are going to do plus or minus. And then we're doing the square root of 4 cubed, right? The square root of 4 is 2, so plus or minus 2 cubed, which is 8. X plus 1 equals plus or minus 8. So then when you subtract 1, you get positive 8 minus 1 is 7, and negative 8 minus 1 is negative 9. It is key that you remember this plus or minus when we're doing even roots. And the thing is, when you're raising it to a 1/2 power, even though it's in a different format, it is still an even root. So think even denominator also gives you the plus or minus. And now, of course, we have to check. And we have to check both. So we're going to plug the 7 in to 2 times 7 plus 1 to the 2/3 power equals 8. So that's 2 times 8 to the 2/3 equals 8. 8 to the 2/3, that's the same thing as saying the cube root of 8 squared, which is 2, and 2 squared is 4, so 2 times 4 equals 8. 8 equals 8. Yay. So 7 works. We also need to check the negative 9. So we have 2 times negative 9 plus 1 to the 2/3 power equals 8. That's 2 times negative 8 to the 2/3 power equals 8. Remember, the cubed root of negative 8 is negative 2, but negative 2 squared is 4. 2 times 4 equals 8. 8 equals 8. This one works too. So both of these solutions will satisfy this equation. 2 times x plus 1 to the 2/3 power equals 8. So you've got 2 answers to this one, and we only knew that because we checked them both. Alright, in example 3, we've got the square root of 3x minus 5, and then minus 3 root x equals 0. So we have 2 radicals in this one, but we only have 2 terms. So in this case, it would be easiest for us if we just moved that to the other side of the equation and then squared both sides. So we're going to take the square root of 3x minus 5 and say equals 3 square roots of x, and then square both sides. And remember, you're doing it to the whole side. So when I square this square root, I get 3x minus 5. When I square 3, I get 9, and when I square the square root of x, I get x. So I have 3x minus 5 equals 9x, negative 5 equals 6x, and x equals negative 5 over 6. So we only have one answer here to check. We want to take, here I'll just write it, check. The square root of 3 times negative 5 over 6 minus 5, all underneath, minus 3 roots negative 5 over 6 equals 0. Before I even do any further work, I see right here that I have the square root of a negative, and that is not real. That is imaginary. Therefore, I know that this isn't actually true. It's not going to work. And you tell me no solution. Or actually, it's no real solution, but no solution is fine. And see, if you hadn't checked it, you wouldn't have known that. You would have put this as your answer, and you would have gotten it wrong. Example 4 says the square root of negative 2x equals x plus 4. And before I start this, some of you are looking at this, and I know a very common mistake is some of you guys will say, oh, I can't take the square root of a negative, therefore this can't have an answer, no solution, be done with it. But that's not true. You have an x under here that is unknown, and if x was a negative number, then you would be taking the square root of a positive, and that's perfectly fine. So don't make that mistake. All right, to solve this, what we're going to do is square both sides. And when I say sides, I mean sides. So squaring the square root of negative 2x is negative 2x. And squaring x plus 4, you're going to have to FOIL this guy. First outer inner last will give you x squared plus 8x plus 16. So now you see that you have a quadratic. And hopefully you remember that in order to solve a quadratic, you have to set it equal to 0. So we're going to add 2x to both sides, and we have x squared plus 10x plus 16. And then once you get there, you can use whatever method you want to solve it. You can factor it, you can use quadratic formula, you can use completing the square. It doesn't matter. This one factors nice and pretty. Factors of 16 that add to 10 are 8 and 2. So we'll say x plus 8 and x plus 2. So that means that x has to be negative 8 and negative 2. And of course, we have to check both of those answers. So we'll take the square root of negative 2 times negative 8 equals negative 8 plus 4. So the square root of 16 equals negative 4. 4 equals negative 4. Well, no, it doesn't. And you're thinking, I know, some of you are saying plus or minus, but this radical sign right here was printed on the page of the original problem, so it was intended to only be positive, and that are only positive. So it's not plus or minus because it was printed only as plus, and it doesn't work. All right, let's check the negative 2. So we've got the square root of negative 2 times negative 2 equals negative 2 plus 4. The square root of positive 4 equals 2. 2 equals 2. That does work. So we're going to cross out the negative 8, and we're going to only use x equals negative 2 as our final answer. And the word that we use for numbers that get crossed out, those solutions are called extraneous. That's a word used to describe an answer that you got using algebra but didn't actually work out when you checked it. Okay, in our last example, the square root of x plus 6 equals the square root of 11 minus x, and then we have minus 3. So because we have two radicals, but we have more than two terms, we have this extra thing over here, we're going to have to square twice in this problem in order to solve it. So the first thing we're going to do is square both sides. And yes, you will have to FOIL this. It gets ugly because we've got 1, 2 terms. You have to do first outer, inner, last. So I'm actually going to write that out for you here. When we square the square root of x plus 6, that's easy, x plus 6. And then I'm going to do square root of 11 minus x minus 3. times the square root of 11 minus x minus 3. So that means first, when I multiply these two together, here, I get 11 minus x, because the square root of 11 minus x times the square root of 11 minus x is 11 minus x. And then when we do outer, we'll have minus 3 square roots of 11 minus x. And we'll do our inner, we have minus 3 more of those, minus 3 square root of 11 minus x. And our last, negative 3 times negative 3 is plus 9. So let's clean this up a little bit. What you can see when we combine like terms is we will have only one radical. So we want to move everything else to the other side of the equation. So I'm going to add x and take away 11 and take away 9. And I get 2x, and then I have minus, let's see, 6 minus 11 minus 9 would be minus 14 equals, and then I've got 3 and 3 is minus 6 square root of 11 minus x. And then at this point, you have options. You could divide both sides by negative 6 if you wanted to. And if it divided into these numbers evenly, I would suggest that. But since this one doesn't, I'm going to say leave it over here on the right. Because at this point, squaring both sides is fine. Because we can square that negative 6. It's okay to have it there. Alright, so when we square 2x minus 14, we're going to have 4x squared minus 56x, because that's 2 times negative 14 is 28, and then 2 of those is negative 56, and then plus 196 equals, and when I square negative 6, I get 36, and when I square 11 minus x, the square root of that, I just get 11 minus x, but make sure you put it in parentheses. Alright, let's move on to the next page. And I'm going to combine like terms. Well, first I'll distribute the 36, so we've got 4x squared minus 56x plus 196 equals 36 times 11, which is 396 minus 36x. So we'll say 4x squared, and then if I add 36x to both sides, we have negative 56 plus 36 is negative 20x, and then I have 196 minus 396, which is going to be negative 200, equals 0, because we always set our quadratics equal to 0. And then these numbers are all divisible by 4. So I'm going to clean this up a little bit. If I divided every single thing, including the 0, by 4, I would get x squared minus 5x minus 50 equals 0. And that's a lot easier to solve. That actually does factor to x minus 10 and x plus 5. So that means that x has to be 10 and negative 5. And that was a very long, hideously awful, ugly problem. But that's okay, because we are perfectly capable of that. And now the very last thing we need to do is check both of these. So I'll move on to a new page, a clean page for that, but we're going to check each of these numbers to make sure that they do or don't work. So I have to go back to the beginning, and I have to say the square root of x plus 6, which we'll try 10 first. So 10 plus 6 equals the square root of 11 minus x, so 11 minus 10, and then minus 3 separately. So the square root of 16 should equal the square root of 1 minus 3. 4 should equal 1 minus 3, but 4 does not equal negative 2, so we know that 10 doesn't work. Try the next one. We're going to do the square root of x plus 6 when we're going to plug in the negative 5 plus 6. Equals the square root of 11 minus x, so 11 minus negative 5 is 11 plus 5, and then minus 3. So we have the square root of 1 equals the square root of 16 minus 3. 1 equals 4 minus 3. Yes, that is true. 1 does equal 1. So the only answer that works of those two is actually negative 5. And so that's what you would write as your final answer. And that's it. We're done with this problem. We're done with this section of notes. So you guys have a good evening. Oh, sorry, I almost forgot. Here's a graph about jokes for you. Math jokes that are funny and that you can understand, that would be right here. And that's my jokes right there. I know you all think that. You love them so much. I know you really do. All right, good night.